In this video, we're going to run a motor start analysis using ETAP. Let's create a new project. This time, let's call it motor start MS. Switch over edit mode. Turn on the grid line as always. A utility. Transformer. Bus. Connecting the transformer to the bus. Extending the bus. This time, in order to have a more detailed example, I'm gonna add a few more loads. I'm gonna add few induction motors by double clicking on its icon. Always try to keep the organization of your one-line diagram nice and clean. This would help in the future and bigger projects. 3 induction motors, 1 lump load, For now, to get an idea about the motor start analysis, let's keep it this simple. Now let's fill the rated kV of the power grid. Let's put it 4.16 kilovolt, 100%. 5 megawatt and 5 MVAR. For the short circuit, 6% X over R and infinite amount of short circuit rating, and click on OK. For the transformer, the primary side is already chosen, and the secondary side, let's put it 480. One of the most used voltage levels in the industry. And let's put 500 kVA. And for the impedance, as always, 6%. And let's fill the rest as typical information. And click on OK. Now for the motor number 1, let's go to the nameplate. Let's have this one the biggest one in terms of the horsepower and put 100 horsepower. And for the full load amp and other data for this motor, let's stick to NEC code. And click on OK. For the next motor, let's put 75 horsepower NEC and OK. Third one, let's put 50 horsepower, again NEC and OK. And for the lump load, let's put 25 kVA. Now to see if everything works good in terms of the power flow, and as a reminder, let's switch over a load flow analysis and run a load flow analysis and run a load flow analysis. Now we may start running a motor acceleration analysis. We click on the 4th icon from the left on the mode toolbar, which is motor acceleration analysis. Inside ETAP acceleration analysis, we can run two types of motor starting analysis. The first one would be static motor starting, and the second one is called dynamic motor starting. With the static motor starting, ETAP calculates the impact of the load being connected to the line directly and would give us some useful information such as the voltage of the load at its terminal, the real and reactive power of the load, and also the voltage dip level at the bus which the load is connected to. But using dynamic motor starting, we will see, considering the characteristic of the load being connected to the bus and using means like variable frequency drive, VFD, we can minimize the impact of the loads at their inrush moments by leading them smoothly to their full load amps. Now let's start the static motor starting analysis by clicking on its icon on the right side toolbar. We will get an error message which states no switching action is specified for up to the total simulation time. This means in order to run a static or dynamic motor starting analysis, we will need to have a set of events in which we will decide about what loads to be connected to the line at what time. To create those events, move your mouse on the presentation mode toolbar and click on Edit Study Case. Switch to Event tab. In this tab, we will have a list of events and the actions specified for each one of them. In order to create the first event, simply click on Add underneath the Events list and enter the name of this event ID. I'm gonna put E1 for the first event, and the time of its occurrence would be the first second. Now we can see the first event is added to our event list. And for the action, click on the Add underneath the Action by Elements list. As you can see, the type of the load is motor. The action would be start, as we want to start the motor being connected to the bus. And if we click on the drop down list next to the motor ID, we will have all the motors on our one line diagram listed, which in this case we're gonna pick the first one. And about the starting category, it tells us whether this motor is a backup, or this motor starts normally, or it's an emergency, or it's an emergency shutdown motor, and so on and so forth. But in this case, we're going to stick into normal. On the lower left side of the window, we will see the total simulation time, which is now 3, but I'm gonna raise it to 12 seconds and click on OK.